applications of PLCs and how to control this is the direction of the motor and how to automate this is the assembly line, okay? For the 3 sensors and also how to drill this is the drill holes on the work pieces. And also there is another one, this is OSR, how to use OSR instruction and to do something useful. So that one is very, very important. So today I'm going to talk about new things, timer. Right, so this is here are today's objectives, and we want to learn the following instructions on timer, TON, and the 2 timers. Okay, one is TON, one is TOX. RTO reset. This is RTO and this is reset. And we also want to learn the simple applications of timer, TON, TOF, RTO, and RES. So 2 timer instructions. Be careful. These 2 guys are different. Okay. They are timer. They are doing they time out. Okay, and they are triggered by different transition. I'm going to show you that. So timer. So you need to define timers. First, you need to know that a timer is an instruction. Right? Instruction. This guy must have a stress. Right? Otherwise, you cannot. You cannot adjust it. You cannot visit it. That is the timer will use this. So each timer address is made of 3 word elements, and you guys are the new generation in the silicon age, right? So how many bits a word occupies? How many bits? 16, right? 1 word means we have 16 bits. Right? So this is know that 3 word. I mean, it's 3 16 the bit, the element. The word 1 is a control word. I'm going to show you, and word 0. See from here, you can see, and all these things they start from 0. As I told you guys, in machine language, in machine language, except the MATLAB. I don't know other high level is a programming language, except MATLAB. MATLAB starts with 1 always. But for all the languages I have used C++, I have used Java, I have used other very, very beautiful languages. They start from 0. Also assembly languages from 0. And word 1 stores the present value. Okay, present value and specified value which the timer must reach before the controller sets the done bit. So you must have a preset value. So I want to preset this time I want to say 5 minutes. 5 minutes too long. I'm sorry. Second, 5 seconds. How can I specify the 5 seconds? No, okay. Another guy wants to specify 45 seconds. And how can I specify that? So this is the preset value. Okay, so the preset value is determined by the operators. The word 2 stores a cumulative value. A cumulative value, as the name suggests, it starts from 0. As you trigger this timer, and this cumulative value is going to go up. Okay, 1 by 1 by 1 by 1 until this guy reaches the preset value. If this guy is equal to a preset value, the done bit is set. That means the timer is out. So this is a time elapsed since the timer was last reset. What enables the timer updates this continuously. This is continuously. So time base determines the duration of each time base interval. So we have second, we have millisecond, and this is a time base. You need to specify, okay? First, if I want to specify time base as a microsecond, and so then I specify preset value, which is usually integer. So that means, for instance, 10 microsecond. If another guy wants to set time base as second, so also preset value, this guy uses the same value, 5 as a 5 second. 5 second and 5, this is microsecond. That's totally different, right? The time base is, and you have an option to change the time base as well. So here is a word description. As I told you guys, a word in the computer world, a word a word occupies 16 bits, okay, from 0 to 15, 0 to 15. So word 1, so this is a control, the commands, control bits, enable time, the done bit for this internal use, right? Internal use, I highly recommend that you don't touch these internal use bits. So word 1, and you can preset, you can specify a preset value, as I told you guys, and this preset value depends on your need, right? So you want to have a timer of 5 seconds, and divide this one as 5, and also specify the time base as second. If you want to define 5 microseconds, and also set this value as 5, and specify the time base as microsecond. Word 2, a cumulative value. This guy starts from 0 as the time goes, and this guy starts from 0 and start accumulating until this guy's value equals your preset value. If this condition is met, the done bit will be set. That means the done bit at the very beginning, the done bit is low, off. When this time is out, this done bit will be set high. Right? You can use this done bit to drive something, to trigger some further event. Right? So enable, this enable, you need to enable it, and TT timer timing, and bit 3 is 13 is done. So this is a done bit. Addressable word. Okay, so this this value is addressable. Addressable means what? Addressable means that you can visit. Right? You can either get the content from it, or you can specify some value to it. That is addressable. Or what does addressable mean? Addressable means that either you can visit this address to get the content from it. This is one way, okay? And for this one, you cannot write anything, but you can read. Another way is that you can write something to this address. That is, read, or if you can read or write, if you can read from or write to an address, that means this address is addressable. Okay, guys? So preset value, yeah, you can specify value here. That means this guy is addressable. ACC, you can read this guy's number, right? Definitely, preset value you can read also. So ACC, accumulated value, you can read the value. Questions? So if I want to test your understanding of the word description, I will ask you guys, and what is the structure of a timer? How many words and this guy occupies? And what they are, right? And how the done bit works? And what is addressable words? What does addressable mean? Addressable means that you can visit it. You can either read or write from this address. That means this address is addressable. Right? Timer. So if you want to define a timer, you must know how to define. This here is the format. Timer, colon, ESB, B is bit. Okay, you need to specify to bit. T is timer file, and F is a file number, and we usually use 4. Okay, and I want to get straight down. And the timer, and we usually use T4. Okay. So this E is element number, and those there are 3 word elements. So S is a sub element. So the element number, there's 3 word elements, and B is a bit. So this is kind of abstract, okay? But when we have hands-on the opportunity to touch the PLC, and you will know how to specify and how to define a timer. Right? Timer is very useful. And we will do a lot of fun things in our lab. The traffic lights is a toggle on and off circuit, and this alarm system, and for this is a high value the strategic this is the targets, and we can do a lot of things using this PLC. And then we talk about the first one, timer on delay, or TON, okay? So I want you guys to pay attention to the difference between TON and TOF. Based on my prior teaching experience, and some students did not pay attention to the difference. They are different, okay? And even though they both of them are timers, but how they are triggered is totally different. So you see, they use TON instruction to turn the output on or off after the timer has been on for preset value internal, right? See, the TON instruction begins to count the time-based intervals when run conditions become true. So this is underscore this one. When run condition becomes true, that means TON is triggered by the transition from false to true. Right? Be very careful. So this guy can only be triggered by the transition from false to true. But another one, TO off, is opposite. So as long as the run conditions remain true, the timer adjusts its accumulated value each evaluation until it reaches the preset value. So as long as there is a transition, the false to true transition triggers and this timer starts counting until the accumulative value reaches the preset value, and then timeout, the done bit is set. Okay? And you can use this done bit and to drive something, to control something. So the accumulated value is reset when run condition and goes false. When this guy goes false, and you lose the track of this timer. Right? And regardless of whether timer has timed out or not, even though this is the timer has not timed out. Present. The most important thing for this slide is that I want you guys to know how the TON is triggered. And TON is triggered by false to true transition. Okay? And we have two different transitions. One is a false to true, go up, that transition. Another one is to true to false, another. Just like this one, I'm talking about this edge. Right? So be very careful. So we are engineers, and we should pay attention to these details. Questions? The online students team, Chase, Yuan, and Toby. Okay, Will, Joe.
No questions.
Okay, so I want you guys pay attention to how the TON instruction is triggered. It is triggered by the transition, the false to true transition, okay? Okay, more insight into the TON status bits. And the bit is set one, this one, and remains set. Okay, set means high, okay? This guy is set, means this guy is set to high value. And this guy is reset, means this guy is reset to low value, okay? Set means this guy is high value. True. Okay? 1 or 1. 0, 1, low, high, false, and true. It's a two value binary system. So timer done bit, this one is the most important bit for timer. When the accumulated value is equal or to greater than the present value. So after the accumulated value reaches the preset value, so this guy will be set and will be on. Right? So remains set until one of the following conditions, run condition goes off, goes false. This guy will be low. Timing bit. The run conditions are true and the accumulated value is less than the preset value. So if these two conditions are met, and this guy TT is high, when this guy will go for will be low, run conditions go false, or when the done bit is set. So timer enable bit. So run condition are true. If run condition are true, this timer enable bit is true. When run condition goes false, so this enable en means enable bit and goes false. Right? Questions? Then TT and en. So here is this is a time diagram for this TON instruction. Right? Here is the time. And here when time is done, and this done is set. Until this enable becomes false. Right? Then we talk about TOF. So TOF is another timer instruction, and this guy also can be used to turn output on or off after its run has been off for preset time interval. See, out its run has been off for preset time interval. So the TOF instruction begins to count time-based interval when the run makes a 2 to 4 transition, right? See? So it is very good idea to memorize two different things, right? To know how they are different. If we know the difference between them, and we can reinforce our understanding. So TOF is triggered by another transition, 2 to 4. However, TON is triggered by the transition of 4 to 2, a different. Right? So as long as run conditions remains false, the increments, the cumulative value increments the timer increments its accumulative value until it reaches the preset value. The accumulative value is reset when run condition goes true, regardless of whether a timer has come on. Right? So these TOF and TON, and they are different, and they can be used under different circumstances. So more insight into TOF status bit, and we also have 3 bits, control bits, then timer timing, and enable. For enable, run conditions are true is that when run condition goes false, they are the same as the TON. But for this one, run conditions goes true, right? When run conditions goes true, accumulative value is equal or greater than the preset value, and the run condition goes false. This is remains set until one of the following. This timer is the same. Run conditions are false, and the accumulated value is less than the preset value. Run condition goes true, or when the done bit is reset. So take a look at this one. So here is a bit, done bit. Right? So this is the T, this is done, this is done bit. I'm sorry, this is not correct. So this is correct. When they go here, the done bit is set. I'm sorry, guys. Here, this one is not correct. I draw this one. This is correct. Right? When time is done, this is a done bit. When time is okay, but here we have this one. So retentive timer. So retentive. So there is one very, very important concept, retentive. I talk about retentive many times. I will talk about retentive many times. Retentive latch, L. Latch is a retentive output. Retentive output means that if you've done something, it will remain there until you do some further action. Right? So that's called retentive. And the RTO use the RTO instruction to turn output on or off after its timer has been on for a preset time interval. to use this RTO. The RTO instruction is a retentive instruction that begins to count the timer-based intervals when the run conditions become true. And the instruction remains its accumulated value. Right? So this is RTO. It's a retentive timer. So here is a more insight into RTO status, the beat. This guy also has on 3 the control beats, Dan, and TT, and EN. Right? So for Dan, accumulated value is equal or greater than the preset value, and the run condition goes false. This guy will be set, right? And the appropriate RES instruction is enabled. The RES is reset. We want to reset it. And the timer timing bit, the run conditions are true, and the accumulated value is less than the preset value if these two conditions are met simultaneously, and this timer timing bit will be set and will remain set until run conditions go false or when the done bit is set. Right? So timer enable bit, run conditions true, and this guy will be enabled. And run conditions go false, and this guy will be reset. Will be low, off, or 0. Questions, comments, remarks? So reset. And reset is an instruction to reset the timer or counter. So this guy, RES, not only we can not only use this guy to reset a timer, but also we can reset a counter. And the counter will be talked about this upcoming Monday. Okay, we talk about timer first, and then we'll talk about counter. Timer and counter can be used together to do a lot of fun things. So when RES instruction is enabled, it resets the TON and RTO. Right? You need to pay attention to this. When the RES instruction is enabled, it resets TON and RTO. However, because RES instruction resets the cumulative value, the done timing and enable bits do not use the RES instruction to reset TOF instruction. Okay? Why? Because TOF is triggered by true to false transition. If you use RES, you just trigger it. You understand? So I told you guys, this is a very good idea. And to memorize 2 things. How to do that? And to compare these 2 things. And know the differences between them. And then knowing the difference between these 2 similar things and can reinforce your understanding. Right? Why I cannot use RES to reset the TOF? Why? The reason is that TOF is triggered by true to false transition. If we use RES, you just trigger it. Right? If you trigger it, this guy starts counting. You understand? If I ask you guys why I cannot, why it is highly recommended that not using this RES to reset the TOF, and you give me a correct answer. The key is that TOF is triggered by true to false transition. If you reset it, and you will send out a true to false transition, and this true to false transition will trigger the timer, trigger the TOF. That's the reason RES should not be used. No? For the TOF. So timer error. So there are some errors, just as we are human beings, we have some errors, right? The input errors can be greater than one full scan cycle input errors. Right? So sometimes the timer cannot capture the transition. Is it possible? It's totally possible. Output errors can be equal to one program execution cycle. Yes. So if we cannot, if we send out something to drive some actuators, if this actuator is not highly compatible with our PLC in terms of timing, and we might lose some command. Okay, so this is totally understandable. Hardware errors, there will be hardware errors, and don't use timers to do accurate timing. Don't use timers to do accurate timing. If you want, say this timing, I need to 9 No, don't do that. Right? So this example. I'm going to show you guys how TON is different from TOF. Based on my teaching experience, some students could not explain this one clearly, but I want you guys to understand, okay? Pay attention to the difference between TON and TOF. And our first example, this is our PLC configuration, electrical configuration. And suppose this is our PLC, and you have wired the system completely. We have two inputs, start, stop. These are two buttons. And one is connected to the beta 1, and that one is connected to beta 2. And we have two outputs, right? On pumper 1 and pumper 2. So, and our customer gives us on following requirement. So, what is the requirement? And when the start button is pressed, okay, if I press the start button and the customer wants to turn on the pump 1, okay, to turn on the pump 1. Okay, after a specified period, sometime, okay, so this is should be adjustable. After a specified period, and the pump 2 will be turned on. So when pump 1 is turned off, if I want to turn off pump 1, turn off, pump 2 is also turned off at the same time. So these three statements are given by the customer. And how can we write a program for our customer and to satisfy these customers' needs? You need to follow these instructions carefully. Okay? Otherwise, the customer will not pay us. Okay? Okay, so when the start button is pressed, turn on the pump. And usually, can somebody for this run, can somebody tell me what we usually call this run? I totally forgot. I need a reminder from you guys.
Start, stop, seal.
Yes, okay. As I said, if you want to build any automation, and always put this one as your first run, okay? So, start, stop, seal in circuit. So, I have a start button, I have a start button. The pump 1 is connected to the start button based on the first instruction. So, if the start button is pressed, then the customer releases the button, and this guy wants pump 1 to be turned on and remain on. So how can I do that? I use the start, stop, seal in circuit, right? So when you seal in, have this seal in circuit, make sure and this output and this input they have the same address. Otherwise, it's not called seal in circuit. You understand? Okay. So this is my first one. After pump 1, if after I turn on the pump 1, okay, then after specified period, turn on pump 2. So this is specified period and can be adjusted. So then I use the pump 1 as input, and then I use the TON, okay, after some time and turn on the pump 2. How can I do that? Turn on the pump 2. How can I specify this one? So once the timer 1 is turned on, so this is the timer will be triggered. And when the pump 1 is turned on, this guy has a transition from false to true. Can somebody tell me on which timer I should use? I should use the TON, right? When the pump 1 is triggered, is energized. That means when this guy status changes from false to true, I want to trigger my timer. I need to use this TON, which is triggered by false to true transition. Okay, I specify this is my timer T4 0, and you can have multiple timers. You can have T4:1, T4:2, and as many as you can. Okay, when you specify, it is a timer space. The timer space, and so this one the unit is second. Okay, and preset value 200, cumulative value is 0, and then I have EN, DON. So after some time, turn on pump 2. This one can be implemented using the round 2. Right? Then, when pump 1 is turned off, pump 2 is also turned off. So this is a done beat. After some time, the pump 2 is, as pump 2 is this is a done beat. I use a done beat and to energize this pump 2. So this is for this one. When pump 1 is turned off, if I turn off this one, and pump 2 is also turned off at the same time. If I press the stop button, and this pump 1 will be turned off, right? Right, guys? If this guy is turned off, so this is a done beat, and will become false. So this guy will be turned off also. Questions? Comments? So the round 2 and the round 3 are combined for our second instruction. And so also this is for the third instruction. If I press the stop button, pump 1 will be turned off. If pump 1 is turned off, becomes false. The done beat will be false. As a result, pump 2 will be turned off as well. Right? When we use timer and counters, the done beat will be used very, very often. And we use the done beat to control some beat or beats. Questions? Comments? Okay, so this is use TON, which is triggered by the false to true transition. And then we look at the second example. Second example is different. Okay, so we have the same thing. Not same thing. Similar thing. Start, stop button. And we have a motor and we have a pump. Now this time, another customer, gives us another set of instructions. So when the start button is pressed, both the motor and its lubrication pump, this is lubrication pump, are switched on. Right? As I told you guys, always put the start still in circuit. If I press the start button and then I release it, the motor will be energized, and because this input instruction and this output instruction, they are sharing the same address. If this guy is true, this guy will be true. So my motor can go this way up. As a result, the motor will be turned on and will remain on. Okay? Both the motor and its lubrication are switched on. Second, when the motor is turned off, when I turn off the motor, when the motor is turned off, what does that mean? It means that this guy, the transition is from true to false, right? The lubrication pump and switch off after a predetermined amount of time. So this timer should be triggered by a true to false transition. And can somebody tell me which timer I should use and why? Yeah, we should use TOF, okay? Because now this time we want the timer to be triggered by this command. This command says that when motor is turned off, means that this guy originally is turned on, is true. turn off is false, true to false. This transition, use this transition and to trigger this is timer. So as a result, we need to use TOF. Right? So if the motor is true, it's okay. Right? If this motor is true to false, so this TOF will be triggered out 200 multiplied by 2.01, this will be 2 seconds. So this guy, the time base, this is a unit is second. This is integer multiplied by this one is a 2 seconds. After 2 seconds, the time bit is set. The time bit is set, then you need to turn off the switch of the pump. See, you need to switch off the pump. Switch for unlatched pump. Questions? Comments? Remarks? So online guys, do you have any questions for me? Corey, Connor?
Yeah, looks good.
Okay. If there is no question, I'm going to recap what we have learned. So this is a timer. Timer is very, very important one, and we can use the timers and to do a lot of fun things, okay? Such as a traffic device, alarming system, and it's talking on and talking off some important circuits. And we will have this fun the activities next week. And we also learned that each timer occupies 3 word elements. And I want to get to know word 0 and what are inside this word 0, what are inside the word 1, and what are inside the word 2. Right? And then I talk about 2 different timers, on TON and TOF. So TON, what is a TON, and how TON is triggered? And we know that TON is triggered by the transition from false to true, right? However, on the contrary, so TOF is triggered by the transition from true to false. So based on this difference, TON and TOF can be used under different circumstances and to satisfy our customers' needs. And then I give you 2 examples, guys. If I give you these 2 examples, one of them or both of them in our quiz or exam 2, and I hope you guys to know on how to explain, right? Okay, questions? So this is what we have learned. So as I said, today, at the very beginning of today's class, I told you guys, and today if you want to get the points back and give me the correction to your problems that you made a mistake by today, 6 o'clock p.m. And also I want to know your team forming, some team forming information. So how many of you guys have talked to your team member? Raise your hand. The online guys, please raise your hands also. Have you talked to someone to form your team? Right? Okay. Okay, guys. Good question. We have 27 students. 27 divided by 6. How many? 4? 4 to 5. 4 to 5. Yeah. Okay. Yeah, 4 to 5. Not 3. 3 is the. We need to have 6. We need to have 6 teams because we have 6. This is PLC units. The 6 groups teams they can operate. They can work simultaneously. Okay. So this one has been arranged very, very well. So I want you guys to tell me by today, if possible, by today, email me information about your team formation, and hopefully by next week, next Wednesday, I want to finalize it, because next Wednesday I want to have our first hands-on lab. Okay? The earlier the better. Okay, and another thing I want to tell you is that for the PLC lab teams, so if you have formed one team, I want the team